The second Newton's law is Newton's second law of motion is probably the more important out of the three. The third one is kind of interesting. It talks about pairing, but the second one's probably the most important, and I will constantly be referring to Newton's second law. The abbreviation I'm going to use is N2L, just something that I picked up actually in college. One professor in particular kept on using N2L as an abbreviation for Newton's second law. Just remember saying, if you see that, I'm referring to Newton's second law. Anyway, what is Newton's second law? Newton's second law says that objects will experience changes in its motion, its velocity. An object will experience a change in its velocity if it experiences a net force. Now, we have to define what a force is in order to really talk about Newton's second law. So, really quick, I'm going to use Newton's definition, and then I'm going to come up with another definition for force. Newton's definition of force is something that can create a change in its motion. It's kind of circular. We've already talked about motion in kinematics. Motion has been in the vocabulary of the world. Actually, force has been in the vocabulary. We've used force before Newton, but Newton really kind of puts a stamp on it. So when we talk about force, we can say that force is nothing more than something that can create a change in an object's motion. It's also important to give it a better definition. I like the definition of forces as any time you experience a push or a pull. Anytime you feel a pull of something, you're experiencing a force. An example is if I take this and I drop this, this object is actually feeling a pull. Okay, so it's experiencing a force at that time. So either one works for me. Anything that can create a change in the motion of an object is a force, or anytime you experience a push or a pull. So the Newtonian definition is anything that can create a change in its motion is a force. The more common sense definition is anytime you experience a push or a pull. You feel a push, you feel a pull, you're feeling a force. Okay, so any one of those can be a definition for force. Anytime you experience, but I'm going to use the push or a pull. It's a simpler definition. So going back again to Newton's second law, Newton's second law says that net forces, if I take an object and I figure out everything that's pushing or pulling on that object, that net forces can create changes in motion. Okay? More specifically, he actually says net forces create changes in momentum of an object. So if you have the momentum of an object, that the net force on that object will actually change that value. Now, remembering momentum is nothing more than mass times velocity. I guess I should have put that on a sticky note up here. Remembering that's nothing more than mass times velocity. So that means forces can do changes in mass, obviously, or changes in velocity. Okay, we tend to lump them together as momentum, but that's what's happening when you experience a force. That's what Newton is trying to say, and I'm just going to express it as this: net forces, and we're going to express net using the summation symbol. Net forces creates changes in momentum. Okay? Cool? Pretty simple? Now we can take it a step further, is that it creates a change in its momentum in a given amount of time. Okay? So moving it one step further, I can say net forces times the amount of time that I experience those forces will create a change in the momentum of an object. Okay? And I didn't say this previously in momentum. I really should have. There's a shorthand notation for momentum, and that's P. Okay? So that means that forces over time can create changes in momentum. Now, in most cases that we'll be dealing with, very few cases will we actually have a change in the mass value. So we can simplify this equation even further. I can say that looking at this, going down to this step, going here, if you're dealing with a special case in which the mass is not changing, I can say that net force is equal to a constant mass times a change in velocity over a change in time. Well, we know from our definition of acceleration, which I have put up on the board for you, is that change in mass over the change, or the change in velocity over the change in time, is nothing more than this. Okay? So there are two equations that are floating around here. The first equation is going to look like this. Once again, take a second to pause the video if you need to write everything down. But the first equation is going to look something like this. Okay? Or I have seen it expressed this way. I should keep track of that. There are vectors in there. So I've seen it expressed this way. I've seen it expressed this way. You can even use a summation, a sigma here, if you're trying to take an integration. But it doesn't really matter. They all are expressing the same thing, that net forces produce changes in an object. And if the mass is constant of that system, then we can say that it produces an acceleration. Okay? That's not always the case. In some cases, forces actually will change the mass of an object. It will liberate, or in cases of collisions, you can gain mass into a system. Okay? Or in the case of explosions, your masses can go in different directions. So you actually, in a sense, lose mass. So the other equation that we've come up with is we've taken the idea of just strictly momentum, in that it's a change in momentum over time. So I get F here times the time in which that object is experiencing. So if you want to think about it, think about this. It's the sum of the forces, and the amount of time that I experience those sum of forces produces a change in momentum. Okay? So both of these equations are coming about. This first one talking about constant mass values, which are pretty typical, especially in my class. The idea of a constant mass is pretty typical. So we can just say constant mass, change in velocity over time, which is nothing more than acceleration. The second one, this summing of my forces, my net force, times time, equals a change in momentum. Well, we call this idea and this idea impulse. Okay? I think I wrote it right. If I misspelled. Oh, I misspelled. There we go. That looks much better. We call these as impulses. Change in momentum is an impulse. Force times time is an impulse. Yeah, I should write that. There's a shorthand nest. You can say F net times time is equal to a change in momentum. That's all impulse. Okay? When we talk about impulse, we're talking about either one of these. It's kind of interchangeable. Now, couple of things really quick. I should talk about impulse on its own. I won't talk about it on this tape, but there's some, or this clip, some really cool concepts are floating around here. Okay? But this is the one we're going to float on for a while when we talk about forces. We're going to go back to Newton's second law quite a bit, but we need to also talk about impulse. Cool? That's Newton's second law in a nutshell.